Welcome all for the today's session. We start today with biostatistics module, and the first topic in the biostatistics module is the data. Okay, so it's the data which is going to be very important. We will require data, everything for the research, for testing our hypothesis and all. So we'll go into the details of data in biostatistics. So what is exactly the data? So data is an information which is collected for analysis or research purpose. So what are the uses of the data? It is used for testing the hypothesis, identifying associations, comparing the groups, and make the conclusions. So basically, in biostatistics, we are going to come across the data, and that is why we need to know what are the different types of data, then how we are going to categorize or the classify, that all we are going to see. So basically, it is the data is of two types. One is a primary data, and or another is a secondary data. So what exactly the primary data is? So basically the data which is collected personally by the researcher for a specific purpose, that is the primary data. Okay, so when the researcher collects the data himself for a specific purpose, then it becomes the primary data. Okay, so what are the methods of collection? The researcher may use questionnaires, interviews, observations, clinical examination, or the lab test. Okay, so there will be questionnaires such as survey on contraception use. There can be interview, it may be face-to-face interview, patient interview. Okay, and then the data will be collected. Then there may be certain observations, labor room behavior study. Then there might be clinical examination on blood pressure measurement. The values will be collected. There may be lab tests such as hemoglobin estimation, etc. Look at the characteristics of this primary data. Okay, so this is actually a original data which is specific to the study objective. It is more accurate, and it has got a control over the quality. It is expensive as well as time consuming. So these are the features of the primary data. So they may ask you that following is not a feature of this either primary data or secondary data. So you should know what exactly the features are. So obviously the researcher is primarily collecting the data from the patients or for a specific study. So the researcher will always try to be very specific, and whatever is required, that particular data will be obtained. So it is going to be an original data which will be very specific for that particular study. It will be more accurate, and the quality will also be good, but it is going to take time. So time consuming, and it may be expensive. But there are certain advantages, that it will be relevant to the study objective. It will be having a better reliability, and the researcher controls the collection method. Okay, and the researcher will have his own collection method. Okay, but there are certain disadvantages, like as I mentioned, it will be costly, time consuming, and it will require a manpower also. Okay, so from examination point of view, you should remember the data which is collected primarily by the investigator, that is the primary data. Okay, the clinical trials usually use primary data. Then you have a secondary data. So data already collected by someone else and reused for the research, that is the secondary data. So in secondary data, the data is already collected by someone, but it is used for the research purpose, that is called as, and the examples are the data which is collected from the registries, hospital records, or the census data, etc. So there are certain registries which are always maintained, like there may be cancer registry, or there may be epilepsy registry, or there may be preeclampsia. If you take out the data from these registries for the research purpose, this will become a secondary data. Same as a hospital records, like a medical records or the census data, population data. Then there may be certain published articles like journal studies, government reports such as NFHS data, or books or newspaper may give the epidemiological reports, etc. Okay, so this all becomes the secondary data. Then what are the characteristics of this secondary data? This is very easily available. It is cheap and quick, and however, the quality of the data will be variable. Okay, and there may be variation also in the collection. Say for example, certain, if you are going through the records, then maybe fundal height, maybe abdominal circumference, somebody might have measured in the centimeters, somebody might have measured in the inches. Okay, and the researcher is relying on the data which is collected by the someone else, so there may be variability. Okay, but it has got a certain advantages, like it will save the time, then it is economical and useful for large data sets. Okay, but disadvantages are there because data may be incomplete, it may be in a different format. Okay, because when we carry out any particular study, we have everything which is operational definition. Okay, we specify that this will be measured in this particular format. Okay, but the available data may not be collected in the same format. Okay, so it may be incomplete, it may be in a different format, there may be possible inaccuracies or bias, and researcher has got no control over the data collection here. Okay, so from examination point of view, please remember, if the data is taken from the existing records, it becomes a secondary data. Okay, so meta-analysis often uses secondary data because meta-analysis is a where we put all the studies together, and all the data which is there in all the studies will be analyzed together. Okay, so it becomes a secondary data. Okay, so let's revise the difference between the primary data and the secondary data once again. So the primary data is collected by the researcher himself. It is very specific to the study. However, the cost is high and the time consuming. Okay, but the accuracy is higher. The researcher has got a control over the primary data. An example is a questionnaire survey. Now, secondary data is collected by someone else. It is collected for the different original purpose. However, the cost is low, less time consuming, accuracy is variable. Okay, the researcher does not have a control over the data collection. An example is a census report. Okay, so that is what is the difference between the primary and secondary data. So this is what we have seen up till now: primary data, secondary data. Examples of primary data are questionnaire, interviews, observations. Okay, so directly researcher is collecting the data. Here, secondary data examples are the registries, articles, government records, etc. So the data is collected from different sources, and the purpose of the data collection, primary purpose was different. However, it is used for the research purpose. Okay. Now, the second thing point to learn is the variables. Okay, what is variable? This word variable we will come across in the statistics. So we should know what is variable. A variable is any characteristic that can change from one person to another person, or it is a characteristic under study. Okay, when we perform a study, what variable change we are looking for. Okay, so it is a characteristic that can change from one person to another. Example like age, weight, blood pressure, sex, then smoking status, etc. Okay, so these are the different types of variables we are most of the time we are studying. Okay, so what are the different types of variables? So these different types of variables may be the concept which they can test you in the examination. So please listen to this concept very carefully. So basically, we have three different types of variable. First is an independent variable, second is a dependent variable, and third is a confounding variable. So these are the three different types. So we'll go into the details one by one. So independent variable. Okay. So independent variable, it is a variable that influences or explains the other variable. Okay. So this independent variable will explain the other variable, or it will give the influence on the another variable. Okay, but this variable itself is an independent variable. Okay, so it is also called as explanatory variable or predictor variable. Okay, so when you are given some scenario and you are asked what type of variable it is, look into the certain key points, such as this is the cause, or this is the intervention which is there, or the certain things are exposed to certain things. Okay, and that leads to something else. So these are the things we should look for, like this causes this. Okay, so independent variable, if you look at the examples, you will understand better. So for example, smoking causes lung cancer. Here the smoking will become an independent variable, while the lung cancer will become the dependent variable, because smoking will lead to the lung cancer. So lung cancer is dependent on the smoking. Okay, hand hygiene, So hand hygiene practice, maybe poor hand hygiene will be associated with diarrhea. Okay, so diarrhea becomes a dependent variable while the hand hygiene will become the independent variable. Same, for example, temperature and the bamboo growth. Okay, so that is how the independent variable and the dependent, basically independent variable is influencing some other variable which is a dependent variable. Okay, so from examination point of view, remember this exposure is concerned, exposure of one particular factor is generally denoting your independent variable. Okay, so next type of variable is a dependent variable. Okay, also called as outcome variable. Okay, or response variable. These are the other names for it. So by definition, outcome or the effect measured in response to the independent variable. So dependent variable is nothing but the outcome or the effect which is measured in response to the independent variable. So key word which you should look for is the when what is the effect or what is the result or what is the outcome, that becomes the your dependent variable. Okay, same we will this example will take the smoking causes the lung cancer. Whole lung cancer is here is the dependent variable, or drug therapy causing a reduction in the blood pressure. So here reduction in the blood pressure is the dependent variable. Okay, exercise and weight loss. So weight loss is going to be an dependent variable here, while independent variable will be exercise. Okay, so the outcome which is measured becomes the dependent variable. Now coming to the third type of variable, which is a confounding variable. Okay, so most of the time they can ask you this particular concept, the confounding variable. Okay, they may give you different definitions. Will ask you the confounding variable means, and 1 2 3 4 5 options will be given. So listen carefully. A compounding variable is associated with both exposure and the outcome that distorts the true relationship between the exposure and the outcome. Okay, so this is the variable which is associated with the exposure as well as outcome. Okay, so uh, basically this variable independently is also associated with the outcome. Okay, so what, for example, here the same smoking leads to the lung cancer. But if you are studying the smoking in a particular group where the occupation itself is responsible for the lung cancer, say for example, smoking in patients with workers of dealing with the asbestos. Okay, but asbestos alone may lead to the lung cancer. Okay, but you are studying a smoking and your population is involving those workers who are otherwise also exposed to the lung cancer, then this occupation will become the confounding variable here. Okay, same, alcohol leads to the heart disease. Okay, then this, if the alcoholic person is also having the smoking, because these two habits may go hand in hand. Okay, most of the alcoholic may be smoker, but the smoking itself is independently associated with the heart disease. So when you are measuring the effect of the alcohol, you are also measuring the effect of the smoking. Okay, so along with that, so if our hypothesis is exactly alcohol leading to the heart disease, then we should not take into the we should try to remove the confounder. Okay, or there are ways by which the confounding needs to be controlled. Okay, so for same example, another is the exercise leading to the weight loss, but those people who follow the exercise are also diet conscious. Okay, but the diet itself is responsible for your either weight gain or weight loss. So the diet itself is an important confounding factor for your outcome. Okay, which is a weight loss here. So this factor which is associated with the exposure as well as the outcome. Okay, so this is independently associated with the outcome. Okay, but it is also associated with the exposure. So when you are measuring the uh, this particular variable with respect to the outcome, then this confounding variable will create certain issues. Okay, so it certain things is that if this variable is unequally distributed in the two groups which you are comparing, then your comparison is not reliable. So if you are comparing two groups and this confounding factor is there, which is unequally distributed, then your reliable comparison between the two groups will be unreliable. Okay, so there are control methods like randomization, matching, restriction. Okay, so other is a stratification, multivariate analysis. Okay, so these are the different methods by which you can control these confounding factors. Okay, so it is not always possible for us to remove the confounding factor, but we can at least control them. Okay, control their effect. So there are certain things which you can take care at the level of the study design, that is the randomization, matching, and restriction. At analysis level, what you can do is a stratification, multivariable analysis, etc. Okay, so certain things about the uh, independent variables and the dependent variables, will revise it again. So independent variable, generally it is the cause of the exposure. It generally influences the other variable, and it is the predict, also called as predictor variable or explanatory variable. Example is a smoking. While dependent variable is the effect or the outcome which is happening, it gets influenced by the other variable, and it is the response or the outcome variable. These are the other names for it. And example is the lung cancer. Okay, doctor, we have few SBS now. Can you try this SBA?
Yes, sir. Question number 1. Example 1. Birth weight is related to adult coronary heart disease. Independent variable is equal to birth weight. Dependent variable is coronary heart disease.
Okay, so this is the thing which is there. They can ask you which is the independent variable, which is the dependent variable. Okay, so it may be either low birth weight or high birth weight. In future, if they have the studies having hypothesis like that, here the independent variable will be the birth weight, while dependent variable will be the coronary heart disease. Okay, second example.
Hand hygiene practices are related to diarrheal episodes. So independent variable is hand hygiene and dependent variable is diarrheal episodes.
Yes. So dependent and independent variable, you will be able to classify. Okay. So another trick is just if and then rule you apply. Okay. If this is there, then it leads to that. So if X changes, the Y will also change. So X variable will be an independent variable, while Y variable will be dependent variable. So apply this if and then rule. Okay. So this is the way you can identify the which is the dependent variable, which is the independent variable. Okay, so if smoking increases the lung cancer, smoking becomes the independent variable, while lung cancer becomes the dependent variable. Okay, so this is the smoking leading to the lung cancer. Here the smoking is the cause and the effect is the lung cancer. Okay, so that is how the dependent and independent variable you should be able to classify. So the types of variable based on the nature. Now this is the another type of classification depending upon their variables. Okay, so variables are basically divided into quantitative variable or the qualitative variable. Okay, now this is the different concept which you should understand, because the question can be asked on this also. So you have different types of variables. Now when it comes to the measuring of the variable, we should know what is the type of variable. Variable may be quantitative or it may be qualitative. Okay, quantitative means you can measure them. Then this quantitative variable may be continuous or discrete. Okay, continuous will take values to infinity, like, and there may be values in the decimals also, while discrete will only the full numbers, while qualitative will have certain qualities only. Okay, so it is a descriptive type of data, or descriptive type of variable which is there, that is the, or certain quality is there, that is the qualitative variable. Okay, now let's see, go into the details of quantitative variable. So these quantitative variables are the numerical variables. They represent amount or the count. Okay, example is the height, weight, income, pulse rate. These you can measure it. Okay, so these are the quantitative and they are numerical variable. However, there are two different types of quantitative variable. One is a continuous variable. So the continuous variable can take any value within the range. Okay, so whatever is the range given, maybe sometimes it may be infinity also, but sometimes, say for example, height or human weight, generally it will have some lowest range to the highest range, but it can take any value even in decimals also. Okay, so it can take any value within the range. Example is a height, weight, blood pressure, serum glucose, etc. Okay, and characteristics that there will be fractions or the decimals are possible here, and this can be measured. Okay, so quantitative variable, quantitative continuous variable maybe in fractions or decimals, and it can be measured. Okay, so these are the measured values. That is a continuous type of variable. Then you have another type of variable that is again a quantitative variable, which is a discrete variable. Discrete variable takes distinct whole numbers values only. So here you cannot have decimal, you cannot have fraction, you will only have the whole number. Okay, example, number of pregnancies. Okay, number of suicide attempts, number of hospital admissions. Okay, number of pregnancies or the number of children, etc. You cannot have 2.5 children. Okay, you cannot have 2.5 suicides. Okay, so characteristic is that it can be counted, but there are no fractions. Okay, so once we can count something, it becomes the discrete variable. Okay, so there is a difference between the continuous and discrete. So continuous is measured while the discrete is counted. Now, continuous can take any value in the given range, while discrete has got whole numbers only. Okay. Then fraction is possible in the continuous, while discrete, the fractions or the decimals are not possible. Example of continuous is the height. Then example of the discrete is the number of children. Okay. Now we have another variable, which is a qualitative variable. This is a non-numerical variable, represent categories or the attributes of the quality. As I already mentioned, the qualitative variable is a non-numerical variable. It will represent the categories or the attributes. Examples are the sex, blood group, religion, marital status, etc. Okay, so here you get person is married or unmarried, religion, A, B, C, D, whatever is the religion of that particular person, blood group, A, B, O. Okay, so you have got a quality. Okay, so this is the non-numerical variable. They represent a particular category or a particular attribute. Okay, characteristic is that there are labels or the categories only, and it cannot be measured numerically. Sometimes you may give the code to them. So for example, male you can code as 1, female you can code as 2, but this is not the numerical measurement. You cannot add them or you cannot do anything with them. This is again becomes a just conversion from one category to another category. That's all. A sort of coding, but that has got no meaning. I hope you are getting this. Okay. Now, what are the types of qualitative variables? These qualitative variables may be nominal variable or may be ordinal variable. Now, in nominal variable, there are categories, but there is no further order within that category. Okay, for example, blood group, religion, sex, male, female, etc. So this is just there are different categories, but within that category there is no further orders. Okay, while in ordinal, there are categories with order or ranking. Okay. Say, for example, pain severity, cancer stage, or socioeconomic class. So, stage 1 has got certain, while stage 2 is an advanced than the stage 1, stage 3 is more advanced than the stage 2 and stage 1, something like that. Pain may be mild, moderate, severe. So, that becomes a ordinal variable. So, qualitative variable is again also again of two types, that is nominal variable, which will these are the categories without any order, while ordinal variables are the categories which has got some order, like pain, cancer stage, socioeconomic status, etc. Okay, so the difference between the quantitative and quantitative is numerical. It can be measured or counted, and examples are the height, weight, while qualitative are the categorical variables. It cannot be measured, but it cannot be measured, and examples are the sex, blood group, etc. Okay, so variables, how we have classified: one is a quantitative, second is a qualitative. Quantitative can be continuous or it may be discrete. Examples of continuous are the height, weight. Examples of the discrete are the number of pregnancies. Okay. Then qualitative may be nominal or ordinal. Nominal there are no intrinsic further categories or the ranks, while ranking is present in the ordinal. Okay, nominal example is a blood group, while ordinal example is a severity of the pain. Okay, so here the number of admissions will be discrete type of variable. Then height is a continuous variable. Blood group is a qualitative nominal variable. Okay, so it is a qualitative and nominal. So we have seen two types of classification. One, this it may be qualitative and nominal. Then pain score, mild, moderate, severe will become a ordinal. Okay. Then smoking in the lung cancer study, it is a independent value. Smoking is an independent variable, while lung cancer incidence is a dependent variable. And age affecting the study result will become the confounding variable. Okay. So this is how the concepts are there, which can be asked in the examination. You should remember independent variable. Generally, it is a cause, exposure, or the predictor, while dependent variable is the outcome, effect, or the response. Okay, confounder is a something which distorts the association, and it is independently associated with the outcome. It is associated with both exposure as well as the outcome, but it itself is independently associated with the outcome. Then continuous variable can be measured. Decimals are possible. Discrete variable can be counted. It is in whole numbers only, and qualitative variable has got a certain categories or the labels. Okay, so continuous can continue like height, weight, blood pressure, etc. And discrete, you can measure or count them with digits. Okay, so number of children, number of attacks, etc. Dependent variable depends on independent variable. Okay, so from examination point of view, smoking is most of the time used as an example in most of the scenarios. So smoking is an independent variable in most of the epidemiological studies. Disease outcome is a dependent variable. Confounders will produce false association. This also you should remember a key point for the examination. Counts are a discrete variable. Measurements are continuous variable, and categories are qualitative in nature. Okay. Doctor, we have certain questions. Please read the questions now.
Yes, sir. Question number one. A researcher studies the relationship between the smoking and lung cancer. In this study, smoking status is a considered independent variable, confounding variable, C dependent variable, D outcome variable. So, sir, answer is C independent variable.
Yes, we have discussed this. This smoking is an independent variable. Okay, so here it is an exposure, cause, or the predictor. Smoking influences the outcome, that is the lung cancer. Therefore, smoking becomes an independent variable. Next.
Question number two. In the clinical trial, reduction in blood pressure after the antihypertensive therapy is measured. The reduction in blood pressure, it is the A independent variable, B confounding variable, C nominal variable, D dependent variable. Sir, answer is D dependent variable.
Correct. Correct. Okay. So it is the outcome or the effect measured after the intervention. Drug therapy is an independent variable. Blood pressure reduction becomes the dependent variable. Next.
So question number three, which of the following is example of discrete qualitative variable? A height, B weight, C number of pregnancy, D serum cholesterol. So answer is C number of pregnancies.
Yes, because the rest of these are continuous variable. Height, weight, serum cholesterol, they are continuous variable. While number of pregnancy is a discrete quantitative variable. It is a quantitative variable. Okay. While these are also quantitative, but these are continuous variables. Okay. So discrete variables are counted and take whole numbers only. Number of pregnancy 0, 1, 2, 3, etc. Height and weight are continuous variable. Next.
Question number four, which of the following variable is measured on the nominal scale? A pain sensitivity, B cancer staging, C blood group, and D socioeconomical status. Nominal. Sir, it is blood group. Answer is C.
Correct, correct. Because rest of the cases where there is a
Order
ranking is there,
follows.
there is a order. Okay. Here blood group, there is no order. Okay. So nominal scale categories are without order. So blood group A, B, ABO cannot be ranked. Next.
Question number five. pain severity categorized as a mild, moderate, and severe is the form of A. Ratio scale, B. Nominal scale, C. Ordinal scale, D. Interval scale. So answer is C. Ordinal scale.
Yes, it is an ordinal scale. Okay, so ordinal scale has ordered categories. Mild is less than moderate, and moderate is less than severe. So exact differences between the categories are not measurable. Okay, difference between the two, but there is a definitely difference, and they are categorized. Okay, next.
Question number 6. Which statement regarding interval scale is true? A, it has a zero, it has a true zero. B, ratios are meaningful. C, temperature in Celsius is an example. D, only categories are present.
Interval scale. Interval scale. This we will be studying in the next session actually. So interval scale, what happens in interval scale? Is there a zero? There is no true zero in interval scale. Ratios are the meaningful, ratios are not meaningful. Okay. So temperature in Celsius is interval. Okay. So option C. Okay. Temperature in Celsius is an example of interval scale. Okay. So there are equal intervals, but there is no true zero. Celsius temperature is the classic example. 40 degrees is not the twice as hot as 20 degrees. Next.
Question number 7. A variable that affect both exposure and outcome and distort the true association is called A. Independent variable, B. Confounding variable, C. Continuous variable, D. Dependent variable. Sir, answer is B. Confounding variable.
Yes. So confounder influences both exposure and the outcome, leads to the misleading association if not controlled. Smoking confounding a relationship between the alcohol and the heart disease. Next.
Question number 8. Which of the following variable is qualitative? A. Pulse rate, B. Weight, C. Height, D. Gender. Sir, it's D. Gender.
Yes, it is a qualitative. Okay, gender. Qualitative variables are categorized. Okay, it is a category or non-numerical. Gender consists of categories. Okay, next.
Question number 9. Which of the following is measured on a ratio scale? A. Temperature in Celsius, B. Pain score, C. Weight, and D. Blood group. Ratio.
Ratio. Ratio is the highest scale. Okay. So here, generally it is a continuous type of data. Weight is going to be the answer over here. Okay. So ratio scale has equal intervals. There is a true zero. Weight has an absolute zero. Ratios are meaningful. That is 80 kg is 2 times of 40 kg. Okay. Last.
Question number 10. A researcher categorized the blood pressure as a hypertensive and normotensive. Blood pressure is now treated as a continuous quantitative variable, ratio scale variable, qualitative categorical variable, and interval variable. So qualitative categorical variable.
Yes, yes. It is a qualitative categorical variable. See, what has happened here? Blood pressure is a what type of variable? It is a continuous variable.
Continuous.
Okay. But what they have done, they have made the categories. One category is hypertensive and other category is a normotensive. Okay. And whatever the values will come, they have divided it under these categories only. So ultimately we are going to deal with these categories. So categories are the it becomes a qualitative categorical variable. It becomes hypertensive and normotensive. Okay. Here the blood pressure intrinsically is a continuous variable. But when we are dealing with this category, that becomes a qualitative categorical variable. You got it? So the continuous variable is changed here to qualitative categorical variable. This concept also is very important. Okay. So qualitative categorical where original blood pressure values are continuous quantitative data. After categorization into hypertensive and normotensive, it becomes the qualitative categorical data. Okay. So from examination point of view, same thing. Independent variable is a smoking. Dependent variable is a lung cancer. Compounding may be age in this particular example. Nominal scale, the blood group is example. Ordinal scale, pain severity. Interval scale, Celsius temperature. Ratio scale, weight is the example. Continuous variable is a height. Discrete variable is the number of children, and qualitative variable is a gender. Okay, so that finishes the topic of data in biostatistics. Thank you.